clear night, no moon in the sky this week, and a great week to stay star curious. As I'm Marquette, I'm so glad you're here at the American Space Museum to stay star curious today. Most Mondays of the week, we're going to talk about being backyard astronomer. What you can see from your backyard, even in the light polluted skies where Dave Stange lives up there in Michigan. So get ready to learn a little bit about your night sky, but also today we're going to feature a story that was released last week that we're going to create a time zone on the moon. Why is that? What's that all about? What are time zones on Earth? We're going to talk about that today, and also there's a new search for a ninth planet. Planet X, I'm going to call it, because Pluto is my ninth planet forever. And I have met the man Clyde Tombaugh before he died, and we should just like we do grandfather Pluto is the ninth planet, but there's a reason it's not, and we'll talk about that today on Stay Star Curious. So glad that you're in my backyard here. This is actually out the very large array observatory out in New Mexico, where they've got several dozen radio dishes that are pointing together, make one gigantic one in the sky. I thought it was an appropriate background here. Thank you, Marty Winkle, for being here and conducting the engineering side of Stay Curious today. So let's look a little bit about what's up in the sky right now and have you talk like an astronomer. Well, if I say today the moon on Monday, May 6th, the moon is 27 days old. What does it look like? Well, there you see 25 days old is a thin crescent. 3 days old is a thin crescent in the evening sky. The 25 days is evening crescent in the morning sky. Yeah, 27 is almost new moon, where we can't see the moon because it's in the daytime sky above or below the moon. Now, the last new moon we had was April 8th. April 8th was the total eclipse of the sun. The moon was in the daytime sky and it passed in front of the sun. Well, I think technically May 7th is the new moon date, and the moon is going to be a little bit above the sun. That's why we don't see an eclipse. Somewhere in the world, though, twice a year, the moon does pass in front of the sun. What a fabulous memory that was all for me up in Ohio with my mother watching it. We've talked about that. Hope you got to see that total eclipse of the sun. It's going to be a while before we see another one here. I think it's 2040 something here in Florida. So good luck for me seeing that. But here's how you talk like an astronomer. 14-day-old moon is full moon. So 14 days later, new moon, our 28-day moon. Also, this is a beautiful time that astronomers are going out to their dark sites to catch things in the moonless sky. The moon wipes out all but the brightest stars. But even when the moon is nearly full, you can see these three star patterns of the Big Dipper. And remember, we've talked about you take the arc of the Dipper and arc to the star Arcturus in the constellation Boötes. Arcturus is very bright, and it's the third brightest star in the sky and kind of looks orangish. So you arc to Arcturus using the arc of the Big Dipper, arc to Arcturus, then speed on to Spica. And Spica is another bright white star in the spring skies, and it is in Virgo, the Virgin Maiden of mythology. Those stars aren't very distinctive, like the Boötes stars look like a kite, and the Big Dipper asterism of Ursa Major, the Big Bear, looks like a dipper there. But on the moonless nights, you can see all these stars a little bit, but they're not really, they're some of the fainter stars you'll see from your backyard. But arc to Arcturus and speed on to Spica, it's right there, up there in the sky to see. And then also about 9 o'clock at night, you look directly to the south and you're going to see a backward question mark of stars dotted by a bright star, another yellowish gold star called Regulus in Leo the Lion. And the back hindquarters of Leo the Lion is a right triangle. All right. All these stars have names. A lot of them have Arabic names, which is interesting because their mythology is Greek and Roman mythology. Arabic names, and then some of the fainter stars, they give them Greek alphabet numbers instead of names. So there we've got Regulus, the regal one, a really bright star that dots the backward question mark, and Denebula, which means tail of the lion or rear hindquarters, is anchors the other end and is a distinctive right triangle that you'll see. Astronomers have maps that show them where the nebulas, galaxies, star clusters are that a man named Messier, Charles Messier, charted in the 1800s, thinking they were these fuzzy things in the sky didn't move. Ones that moved became comets. And so the ones that didn't move, he gave them a category number. And they end up being a wonderful treasure of celestial objects that people cut their teeth on when they buy their first telescope, the Messier objects. Messier 105, 96, and 95 there are galaxies far, far away, like 30 million light years away. And here they are from the backyard of my friend Mark Poole on India Atlantic, on the shores of the Atlantic Ocean, down the coast here from Titusville. So this is a kind of if you could put binoculars up there, these binoculars, this is, and I could see the galaxies like this if the binoculars gave me that much light on the galaxies. So, and of course, you can look at individual galaxies with more power, but kind of gives you an idea what these faint fuzzies look like from an amateur photographer's backyard. Mark Poole, a friend of mine, some very basic astrophotography here going on. So keep looking up in the night sky. The spring sky is particularly rich in galaxies in Virgo and Ursa Major, the Big Bear, and Leo. And get you a star map. You can download those. I'll show you one next week when we talk about star maps on Staying Star Curious. So we thought we'd give a little bit of news today, a basic painting of our solar system all crowded together there. We now think of 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And those are sort of the scale. Jupiter and Saturn would be a lot bigger on this scale. Jupiter, Saturn, Uranus, and Neptune all have ring systems. Only Saturn's is visible from backyard telescopes. But we used to have Pluto. My shirt says it all. Forever Pluto there is a planet. And it was demoted as a planet because it was discovered that Pluto is in an area of our solar system called the Kuiper Belt. And there were 4 or 5 other objects in the Kuiper Belt bigger than Pluto. So are we going to add 4 or 5 new planets or classify these special objects around Pluto's orbit as dwarf planets? So that's what we did. And to make things clearer as mud, of course, to some of you that don't follow that, but basically the solar system is filled with a lot of unknowns, and in the news this week was a search for a 9th planet. All right. And I'm going to just call it Planet X, just like Pluto was Planet X when Neptune was thought of as the 8th and furthest planet for many, many decades. And then in 1930, Clyde Tombaugh, through photography and comparing where faint stars were moving, and discovered that Pluto was one of those. Clyde Tombaugh discovered Pluto in 1930 at the Lowell Observatory. Well, there are some things going on in the solar system that are moving different objects around at different rates, enough that we think there might be a large Neptune-sized planet way beyond Pluto out there. And it's called the 9th planet, or Planet X. And here's a chart to sort of tell you a little bit about what the Planet X is all about. Planet 9 there, and the sun is shown here, and another close stars in the background there. These are all asteroids, and Sedna is another dwarf planet bigger than Pluto that orbits in the Kuiper Belt. And I'll show you that Kuiper Belt. Well, there's more hypothetical evidence that planets lurking beyond our solar system, way past Pluto and Neptune. Planet 9, as it's referred to, is first suggested in 2016 by 2 Caltech astronomers, Konstantin Batygin and Michael Brown. And Michael Brown discovered the dwarf planet Eris in 2005, which started the crumbling down of Pluto being demoted because Eris is another body that was fairly large. And they call these trans-Neptunian objects, TNOs. Well, because the solar system is formed like a disk, think of a pie plate, okay? And on that pie plate is the plane of the planets, like I showed here, all right? So, but if you've got the pie plate thickness is where we find the planets going around in pretty much orbits that are elliptical, but Pluto and these other dwarf planets come at different angles through that pie plate, like way above it and way below it. And we know that they, like we see here with these asteroids and Sedna. So the gravity from something lurking beyond Neptune is pulling objects out of the ecliptic and bunching them together in highly elliptical orbits, like this right here. Jupiter is so powerful and so large in our solar system that it has its own little system of asteroids that are in front of it and behind it. And we have got a spacecraft headed to investigate those called Lucy that's going to intercept some of these Jupiter asteroids that could be rich in life-giving forces, or they could be dead comets. All right. The difference between an asteroid and a comet orbiting the sun is comets are like dirty snowballs that are filled with ice, where the asteroids and smaller objects are rocky. So we take Neptune, is at the edge of the Kuiper Belt. The Kuiper Belt is a little area, sort of like the huge area actually, like the asteroid belt between Jupiter and Mars, where there's rubble there instead of a planet. Well, the Kuiper Belt is again leftovers from the creation of the solar system, and the Pluto is way out there in that Kuiper Belt. Neptune is 2 billion miles away. As you see by you've traced the object, the erratic, elongated elliptical orbit of Pluto, for about 20 years from 1970 to 1990, it was inside the orbit of Neptune and closer than Neptune. So this is what the anomaly of Pluto and these other dwarf planets that created a whole separate category for them. So there's all these objects in the Kuiper Belt. We've got the New Horizons spacecraft has investigated several of them and is going to another one of them. We don't understand why these were leftovers. It's so cold there. Pluto, though, is a very dynamic world, those 200 below zero there. Now we go beyond the Kuiper Belt, up at the top square up there. The orange track represents Pluto's orbit, is yellow, and another Kuiper Belt object like Eros could be the other one there. Well, as you see, this Kuiper Belt is just real tiny inside of this gigantic sphere that's engulfing the whole solar system that we call the Oort cloud, named after a Danish astronomer named Johan Oort. This cloud has been theorized. There's no theoretical evidence for it, but we think this is the reservoir of comets that, like a gigantic bubble, encases the entire solar system with the leftovers from the creation of our planets and sun. How big is this? It could stretch 1 light year, maybe, in distance, or 2 or 3 light years across, all right? The closest stars to Earth are about 4 light years away. The Alpha Centauri system, about 4 light years away. Light that we see of that system took 4 years to reach us. So we think that this Oort cloud is maybe halfway to the next star system. And these Voyager spacecraft are still in the Oort cloud, though they've technically left the solar system and are way beyond the Kuiper Belt at about 10 billion miles from Earth. Now, Pluto ranges from 4 to 2 billion miles from Earth in its elliptical orbit in this Kuiper Belt. So this is where we're going to find this planet X, or the 9th planet, somewhere lurking way out there in the Oort cloud. Why can't we see it, you ask, with our most powerful telescopes like the Hubble and the Webb orbiting the Earth and all these arrays of telescopes on Earth? Because it is dark. All right, there's not much light to illuminate its surface, so it's evasive that way. But they're judging by the pull of gravity that this has on it. Think of putting 2 magnets together, and they if you have the positive and the minus ends to each other, they connect. If you have two positive ends or two negative ends, you can't connect them, and it's fun to kind of play with them, and you feel that tension, a magnetic rolling around as you try to connect two positive ends of a magnet. This is how gravity works in our solar system and, in fact, the entire universe. So we'll keep looking up for a ninth planet, Planet X. The ninth planet was truly discovered in 1930, okay, by Clyde Tombaugh at the Percival Lowell Observatory, who was a very big popularizer of astronomy. In Mars, Percival Lowell popularized 100 years ago in very best-selling books that Mars was an abode for life and a dying planet, and we could see the canals of its waterways trying to keep it alive. And then, of course, in 1965, Mariner 4 flew by Mars, took the first 22 photos, and showed a crater world with no forests, a very thin atmosphere, and shattered that whole concept by Percival Lowell. Well, that Mars was a dying world with inhabitants on it. 100 years ago, astronomers thought most of the solar system was full of life. There could even be life on the moon, that some of them thought. Well, there is the beautiful picture that New Horizons took of the globe of Pluto. As you see, it's got different features on it, and what we're looking at is that heart-shaped object is a frozen slush, really like slush of nitrogen, 300 below zero, and these mountains are mountains of nitrogen floating on that. And you see the impact craters and so forth, more of a dynamic world than we ever thought of. We thought we were just going to find a boring frozen ball of Pluto, but we need to go back there because it is very interesting. Here's Pluto in relationship to the Earth and Moon, all right? And it has a moon called Karan, Charon. Pluto and Karan's about half the size of Pluto. Pluto's about half the size of our moon. And our moon is 1/4 of the size of the Earth, 2,000 miles across to the Earth's 8,000. And between the Earth and the moon at 4,000 miles across is Mars. So that's the relationship of some of these small objects we're looking at. Pluto would just fit very cozy in our borders of our United States. Well, let's go on to something else here after I show you a picture of the great Clyde Tombaugh. Rest in peace. I was honored to meet this man a couple times. He was a real popularizer of astronomy, just a wonderful, congenial man, and did a lot for our space program, by the way. Clyde Tombaugh, many don't know, pioneered some of the optics to follow rocket launches and to have cameras taking continuous movies of the rockets as they ascended out there in New Mexico, his native state out there. So never will forget you, Clyde. Pluto forever a planet in my mind. Well, Marty, let's move on to another item that was in the news this week, is that the moon is going to get a time zone, all right? What's that all about, you said? A time zone? Yeah. We found out that precise time is needed for the Artemis program and everybody going to the moon, China, India, everybody is got now probes going to kind of a gold rush, a water rush, if you will, at the South Pole of the moon, because we know there's water buried underneath that lunar soil. Is it like that Gold Rush TV show where you harvest 2 tons and get a little thumb of gold, the thumb size of gold? It might be, or there might be sort of like ice cubes underneath there waiting to be harvested. That ice came from comets, by the way. Well, we need a precise time, and the White House instructed NASA to come up with a lunar coordinated time zone that will be used in operations in cislunar space around the moon, and so that everyone can be coordinated time-wise. Now, this was necessary because we have a 24-hour day, almost exactly. Well, the moon moves more quickly, and in fact, its day is 58.7 microseconds quicker than Earth's day. This is because the moon's gravity is weaker, And the weaker gravity, the faster time runs. Don't get your head wrapped too far around this. Just take it for granted, because this is really heady stuff. That 58 microseconds might not sound like much to worry about, but an eye blink, for example, is about 100,000 microseconds, all right? Or a tenth of a second to blink your eyes. The time discrepancy is crucial for space missions that require extreme precision for communication, tracking, and navigation. Lunar time coordinated is also needed to secure data transfers between spacecraft and for matched communications among the Earth, lunar satellites, and bases of astronauts in those orbiting and on the moon once we get them there. And because future missions will be multinational, all participants need to be synchronized, all right? So they're very serious about this. Of course, they need to be. Now, why wasn't this needed in the Apollo era? Marty's asking me, because he worked on the Apollo era. That's because time wasn't kept as precisely in the Apollo era. Think about the Apollo lunar module landed with a computer that had 56 kilobytes of memory. Those of you under 30 don't even know what the heck a kilobyte is, but 1,000 kilobytes is a megabyte, and 1,000 megabytes is a gigabyte. So Ks, megs, and gigs quickly escalated as we got better at making computerization things. So you had 56K memory landing on the moon, all right? I think if you get a Hallmark card that sings to you, you open it up and it's automatic, that's got a lot more memory than that had, than 56K. So we have a lot of memory going. Memory's been compressed. We've got faster speeds going back and forth talking to spacecraft now, 50 years later from Apollo. So it needs to be upped and more precise to keep up with this 58 microseconds of delay that the moon experiences. So that's a need that we have on Earth. So be it. We're going to have lunar time being kept. But here on Earth, we've got the time zones. There are 30 time zones across our great globe. And this is why. Early navigators going across the world had to have a point with their sextants they used to know where they were, so that they knew when are they going to get to across the ocean, or to different, even from Europe, get to Italy, all right, through the Straits of Gibraltar and stuff like that, going through time zones. So measuring latitude, how far you were north or south of the equator, was easy. But measuring your longitude, how far you were east and west, was another matter. It was known in the 17th century that the Earth turns 360 degrees every day, or 15 degrees an hour. So if you traveled 15 degrees eastwards, local time moves 1 hour ahead. Traveling west, 15 degrees, local time moves 1 hour back. We, of course, are familiar with that here in America, because if it's 4 o'clock Eastern, it's 3 Central, 2 Mountain, and 1 Pacific, all right? And Alaska is then the next time zone over at noon. And then Hawaii is another time zone over again. It'd be 11 a.m. if it's 4 o'clock Eastern here on the space coast of Florida. You all understand that. But to get the longitude, in 1675, King Charles II appointed a man named John Flamsteed as the first royal astronomer of the new Royal Observatory of Greenwich, London. The empire needed a method for navigators to find their position at the sea, in the sea. Does anybody really know what time it is? Does anybody really care? And you'd have to be over 40 or 50 to hum that beautiful song from the band Chicago from about 1968, all right? I got that rhythm going, rhythm section going. Does anybody really know what time it is? Asking a man on the street, and he said, does anybody really care? So, yes, we do care. Time is very important to everything celestial and everything on the surface of the earth that is being transported from one place on earth to the next. Here is the famous Royal Observatory of Greenwich, London. And I want you to notice on the white door, right there's the white door. And at the bottom of that white door is a bunch of bricks and a piece of iron there. This building is even split in two to open it up. There's an observatory on the back there. This is called the Flamsteed Observatory, of course, after John Flamsteed, the great astronomer there. He installed state-of-the-art pendulum clocks by the best clockmakers in the world and set these clocks to local time, which was called Greenwich Mean Time. All right, I meant to put a pendulum in there. That's that swinging thing that can keep time as the Earth rotates, and another amazing invention of early astronomers. Well, Flamsteed started cataloging stars and it became the standard reference for plotting star positions based on Greenwich Mean Time. And there is the line on Greenwich, London, that separates the Western Hemisphere from the Eastern Hemisphere, okay? And this is where base 0 is for Greenwich Mean Time, that all time on Earth is based, your 24-hour clock. All right, so what kind of 24-hour clock do they use to keep time? Atomic clock, cuckoo clocks, wind-up clocks? No, they're the atomic clock kind. And here's what one actually looks like, believe it or not. That is a clock with a couple scientists adjusting things on it, probably. They use a ultra-precise atomic clocks around the world where radioactive material that denigrates is the source that they keep time on. It's very complicated, but trust me, there's 30 atomic clocks like this around the world to keep precise to the microsecond time. And that's what we're doing, going back to the moon, is creating a time zone for Artemis, for the Chinese program, for the Indian space program, to all be coordinated to the precise microsecond. When we get people on the moon, and we fully expect China to be there before anybody, that is another subject for another Stay Star Curious. But this artist concept of us on the moon at the South Pole is, we hope that happens, and we hope it's a lot of Americans there, but they're going to need a time to know when to do things. For after all, it's always 5 o'clock somewhere and ready for happy hour, right? It's 5 o'clock on my hometown of Findlay, Ohio, at the Hancock County Courthouse. And that's a photo I took of John Hancock up there on top of our courthouse there. So it's always 5 o'clock somewhere, Marty, and that is the good news to end our Stay Star Curious program today. Hope that you've all enjoyed looking up at the skies a little bit. This week is a great week. All my astronomy friends are scurrying around their favorite sites, looking at those galaxies in Leo, Virgo, and Ursa Major, as well as enjoying some dark skies to see satellites going overhead, and seeing some maybe at the space station. And I saw the Chinese space station the other day. And I made it on my notes here that we don't have any Jupiter. We're losing Jupiter in the night sky, so no major planets to see unless you get up early in the morning, which is 6:30. 6 is sunrise this week, and sunset is 8 o'clock. And we're gaining about 2 minutes each day, one minute early in the morning and 1 minute later in the evening, until that old sun's going to be setting about 9 something at night here in June. So get out there and get you some starshine. Get underneath the beautiful sky of your backyard. You'll enjoy the sounds of the night with the animals, the insects, and the quietness of our beautiful world of heavens above us there. So until next week, when we're going to stay star curious, I'm Marquette saying I can't wait to see you under the stars to bridge the space between us.